The reason we need significant figures is really because we take those measurements that we make and we do calculations with them. When we do a calculation, we can't have the amount of uncertainty changing. You can't say, well, this thing is 1 foot long, and really you're meaning it's between 0 and 2 because you're just kind of estimating. It's 1 foot long, so if I take this piece of wood and I want to cut it in 3 pieces, each of them needs to be 0.33333333333 feet. That's not going to work because the original measurement was to the nearest 1 foot. When you divide by 3, you can't make that measurement magically more precise. So significant figures allow us to keep track of this in calculations without using differential calculus. Differential calculus is the more rigorous method, but I don't think anybody in this room wants to do that, myself included. I had to do it in P-Chem in college, and it was fun for a while, but, when the class was over, I promptly deleted that from my brain. So when we use numbers in a calculation, we're going to round the result to reflect the significant figures in the measurements that we started with. Sometimes calculations have multiple steps. You have to add these 2 things, and you take that result and you multiply it by something else. When we have multiple steps, we do not want to round off until we get to the final answer. If you round each individual step, you're going to introduce error into your calculation. So there are 2 basic types of operations that we do on numbers. Multiplication and division are related to each other. You could think of them as opposites. We'll talk about this one first. So when we have multiplication or division, the result will have the same number of significant figures as the factor, the thing we were multiplying or dividing, that had the fewest number of significant figures. I'm giving you the easier rule first. It's also more important in 3A. So then we just learned how to count sig figs. So what we're going to do here we've got multiplication. And this is what your calculator would show you. And then we need to round that off. So we're going to look at this number, 5.02. How many significant figures does it have? 3. And 89.665 has 5 significant figures, and 0.10, 2. Very good. Leading 0 doesn't count, trailing 0 does because there's a decimal point. Here's the hard part. Which number is smaller, 3, 5, or 2? 2. Like, wow, that wasn't hard. 2. That's the number of significant figures we should have in our answer. So here we've got the 4 and the 5. That's 2 significant figures. We need to round it off to the nearest 1. So we're going to look at the next digit. So we're going to keep these 2. We look at the next decimal place. It's a 0. That's less than 5, so we're going to round down. Because this number is closer to 45 than it is to 46. And I know you did rounding in elementary school because my kids do it. They bring home homework. So we're going to record that answer as 45. Here's another one. This is one number divided by another. This is what your calculator will show you. Your calculator does not understand significant figures. It's okay. So how many sig figs in 5.892? 4. And how many in 6.10? 3. I also heard some 2s. Well, the 6 and the 1 are obviously significant. The 0 is where we get a little tripped up. Trailing 0 with a decimal point. We're going to count that. Another way to think of it is if we lost that 0, would that change the number? Would it change the magnitude of the number? It'd still be 6.1. That's like almost the same as 6.10, right? If you can lose the number and then if you can lose the 0 and the number doesn't really change, it's probably a significant digit. The place-holding zeros, you take them out, and all of a sudden your number has changed by orders of magnitude. So we identify the number of sig figs, then we ask ourselves which one's smaller. That's the 3. So that tells us we're going to keep 3 significant figures in our answer. So 9, 6, and 5. That's 3. Now your calculator might also show you 0.9659, 0.1639. Do I count this 0? No, it's a leading 0. Like, well, why do you write it there anyway? If I took it off, it wouldn't change anything. We almost always write a 0 before a decimal point to call attention to the decimal point. Decimal points are small and they're easily overlooked, especially if you're writing on a poor paper with a bad pencil. You make a dot for the decimal point and maybe it's hard to see. If you put a 0 before the decimal point, it kind of says, hey, look, there's a decimal point after me. Because that's the only time we start a number with 0 is when there's a decimal point coming up. So we don't count the decimal point. We're going to keep the 9, the 6, and the 5. And then we look at the next digit we're getting rid of, the 9. 5 or greater, we round up. That means that this 5 goes up to a 6. So 0.966. Because this number is closer to 0.966 than it is to 0.965. Any questions? So I already demonstrated rounding, but here's the official slide on rounding. Use only the first digit that's being dropped. Your book talks about the leftmost digit. If that makes sense to you, great. It just doesn't make much sense to me. I think about the first digit I'm going to get rid of. That's the only one that you need to look at. If it's 4 or less, if it's less than 5, then you round down. If the digit you're dropping is 5 or more, then you round up. So 2.33 would round to 2.3 because this number that we're getting rid of is less than 5. 2.37, if we're rounding to 2 significant figures, we'd round up to 2.4. Okay, if you have your calculators, get them out. You should always bring your calculator and pull it out and do the calculation with me. Because it's just so much fun when I make a mistake and you get to call me out on it, right? So the first thing you should do is just do the calculation on your calculator and write down the whole answer. So that's what I'm going to do. 1.10 times 0.512 times 1.301 times 0.005 divided by 3.4 equals and my calculator is showing me 0.0107753412412. Everybody okay with that? Your calculator may have more digits or fewer digits. So we write it all down, and then we look at the types of operations we did. We've got multiply, 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 divide. As long as it's just multiplying and dividing, we can use the rule that we just learned. So we're going to look at each of these numbers and see how many sig figs. 1.10, how many sig figs? 3. 0.512, how many? 3. 1.301, how many? 4. 0.005, 1. What? Yeah. The leading zeros, they don't count. It's just the 5. 3.4, how many sig figs? 2. So, what's the smallest one? The number 1. So we're going to round it off to one significant figure. So we don't count these zeros. Leading zeros are not significant. Otherwise, we'd end up rounding this off to 0, right? The zeros don't count. We're going to keep the 1. We look at the next digit. It's less than 5. We round down 0.001. That's our answer. Now, it is also okay to report that in scientific notation. That would be 1 times 10 to the minus third. In my opinion, it is never incorrect to report a number in scientific notation unless the question is specifically telling you that it wants it in decimal notation. My kind of rule of thumb for using scientific notation is if I can't just look at it and see how many zeros there are, put it in scientific notation. I can look at this number and see that there's 2 zeros. I don't need to get my finger out and count zeros, right? And, so that's kind of a personal thing. Any questions about that one? Let's do the next one. 4.562 times 3.99870 divided by 89.5. I think it's always a good idea, if you have the time, to do a calculation on your calculator twice. If you get the same result, you probably did it okay. If you pushed a button wrong, you'll probably do it differently the second time. You'll come up with a different answer. And then you do it a third time and go for best 2 out of 3. Anybody else get that number? Okay. So, how many sig figs in 4.562? 4. And in 3.99870? 6. The 0 counts because it's at the end. It's a trailing 0. There's a decimal point. 89.5. 3. So of those, 3 is the smallest. We need to round this to 3 significant figures. That leading 0 doesn't count. We're going to keep the 2, the 0, and the 3. And we look at the one that we're getting rid of. The 8. That tells us to round up. So we're going to say this is 0.204. Any questions? Sometimes students will say, but it looks so easy when you did it. Well, it looks easy when I do it because I've been doing it for years and years and years, and it is easy for me. Once you practice, it can become easy, but you got to do some practice. Okay, other type of operation, adding and subtracting. This one, it's harder to give you a rule in words. So I'll just go with what the book says. The result carries the same number of decimal places as the quantity carrying the fewest decimal places. Multiplying and dividing, we were talking about number of significant figures. Here we're looking at number of decimal places. There's a difference. So if we look at this addition, 5.74 has how many decimal places? 2. And 0.823 has how many decimal places? 3. 2.651, how many decimal places? 3. So we want our answer to have 2 decimal places. So when you do this on your calculator, 5.74 plus 0.823 plus 2.651 equals, my calculator is showing me 9.214. My analysis tells me it can only have 2 significant, not 2 significant figures, 2 decimal places. These 2 decimal places and anything that comes before that. So I'm going to report this as 9.21. So let's look at this in a different way. People are different, their brains work differently. Usually what I'll do is I'll present the explanation that works for most people based on my experience of teaching this class for many, many years. If my explanation doesn't make sense to you, then you should ask me. Lab is a great time because for most things, I've got like 3 or 4 different ways I could explain it to you, and one of those might make more sense. But on this one, I'm going to give a couple of different explanations. So that's one method. Another way is to look at these numbers and underline the uncertain digit. That's the last digit. So in 5.74, the uncertain digit is a 4. 0.823, the uncertain digit is a 3. 2.651, the 1 is uncertain. Okay? In our result, we want all of the certain digits and 1 uncertain digit. So now what we're going to do is we're going to go left to right, looking at these columns. Any uncertain digits there? No. The tenths place, any uncertain digits? No. The hundredths place, there's an uncertain digit. So what that tells me is that come on, little guy here. That's where my number has to stop. I want to include the first column that has an uncertain digit in it. So my calculator shows me 9.214. This 1 is uncertain. I only want to include the first uncertain digit. So that explanation might make more sense to you. When you first start doing this, you might need to stack them up, line up the decimal points like you were going to do do it by hand so that you can see what's going on. After a while, you might get more comfortable with it and you won't have to do that anymore. Let's look at this one, 4.8 minus 3.965. So let's just do it on the calculator first. And see what the calculator says. So the calculator is showing me 0.835. Let's use the first method, looking at number of decimal places. How many decimal places in 4.8? 1. 1 decimal place. There's 2 sig figs, but we're subtracting. We're counting decimal places. How many decimal places in 3.965? 3. So 1 is smaller, and so we should take this 0.835 and round it off to 1 decimal place. And so we're going to call it 0.8. Let's do the other method. 4.8, the last digit is uncertain. 3.965, the last digit is uncertain. We go left to right, the ones column, there's nothing that's uncertain. The tenths column has uncertainty. We've hit the first column that has uncertainty, and we're just going to draw a line down there, and that tells us where to stop our number. We're going to stop with the 8. We look at the next digit. It's less than 5, so we round down and we get 0.8. Any questions? When you're adding and subtracting, the answer can end up with a completely different number of significant figures than anything you started out with. So let's do this example. 28.02 minus 27.99. Calculator says 0.03. 0.03. Well, how many is that right? Do we need to round it off? Well, how many decimal places in this one? 2. And in this one? 2. So we should have 2 decimal places in our answer. If we were to stack it up and do it that way, we'd come up with the same result. So this one is correct as it stands. the numbers we were subtracting each had 4 significant figures. The one we're left with has 1. It happens. Sometimes you end up with more significant figures than you started with. It can happen in adding and subtracting. If that bothers you and you want to talk more about it, I'd be happy to explain it more. There's a lot more I could say, but most of us don't need to know anymore. Any questions? Do you need more examples of this, or are you good? Good, okay. What if you have operations all mixed up together? Multiplication or division with addition or subtraction. Then we have to be careful, okay? Do the steps in parentheses first. Follow the order of operations. If you don't remember that from high school, is please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, subtraction. That's the order. Do the individual parts first. Look at those results, those intermediate results, and identify where the uncertain digits are, but don't round them off. Do the remaining steps, come up with the final answer, and round based on looking at the sig figs in those intermediate answers. So that doesn't make a whole lot of sense. Let's do an example. Perform each calculation to the correct number of significant figures. So here we have 3.897 times the quantity 782.3 minus 451.88. So here we have parentheses. We're going to do that part first. 782.3 minus 451.88. I'm going to write that value down, but I'm also going to leave it in my calculator. So that difference is 330.42. Then let's think about significant figures. Well, we're subtracting here. We have to use the subtracting rule. This has 1 decimal place. This has 2 decimal places. So how many decimal places should this result have? 1. So that tells me that the 4 is an uncertain digit. Okay? I'm not going to round it off yet. I'm just going to leave it there, but I'm identifying that's the uncertain digit. And of course, everything after that is like completely just crazy, but we'll just leave it alone. Then we're taking this number times that number. So we're going to finish out the calculation. I'm going to go times 3.897 equals, and my calculator gives me this big old mess. 1287.64674. If I make a mistake, just holler at me. So that is not the correct number of significant figures. Here now we have multiplying. So we need to use the rule for multiplying. There we're looking at number of significant figures, not number of decimal places. So how many significant figures in 3.897? 4. So there we've got 4 sig figs. And 330.42, we underlined the 4 because that was an uncertain digit. The significant figures include the first uncertain digit. So this number also has 4 significant figures. The 2 is just getting carried around so that we don't have any rounding errors. But he doesn't get counted. So this has 4 sig figs. So then our answer should have 4 significant figures. So that's these first 4 digits. The first one we're getting rid of is a 6, which tells us we need to round up. And we record our answer is 1288. Any questions? Let's do the next one. Here we have 4.58 divided by 1.239 minus 0.578. Well, let's look at what's inside the parentheses first. 4.58 divided by 1.239. So that is 3.696529,459. What a mess. It's a division problem. How many significant figures should that result have? 3. Because this factor has 3 and that one has 4. The smallest number of significant figures. So this guy has 3 sig figs. Then we're subtracting this number. So I'm going to subtract that, 0.578. And my calculator is giving me an answer of 3.118529459. Subtracting, we have to look at decimal places. How many decimal places are significant in this number? Decimal places. 2. 3 sig figs, 2 decimal places, the 6 and the 9. We include the first uncertain, but nothing after. And then over here, we've got 3 decimal places. So our answer should be rounded to 2 decimal places. So we would record this as 3.12. Let's look at this one stacked up. So I'm gonna bring this guy over and stack him. 0.578. This one's uncertain. We're subtracting. The ones place, there's no uncertainty. The tenths place, there's no uncertainty. There's uncertainty in a hundredths place. So that's where I'm going to cut off the number. 3.118, blah, 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 blah. Okay? Questions? Did I take this number and round it? No, I didn't. No. I wrote the whole thing down more for illustration purposes. It was still in my calculator, and so then I just subtracted after that. It's best to avoid writing intermediate values down, because when you write something down, you can make a mistake. When you type it back into your calculator, you have another opportunity to make mistakes. We want to minimize how many mistakes we can make. Yes?
How do you define the uncertain number again?
Well, we're going to assume that all of these numbers are written correctly as scientific measurements, and so the last digit is always uncertain. And then we follow the rules. If we're multiplying, we look at the numbers that we're multiplying, and we find the one with the fewest number of significant figures. If we're adding or subtracting, we're going to look at the number of decimal places and decide how many decimal places the answer should have. Now, the good news is that when you have mixed calculations, it's actually a fairly rare occurrence in Chem 3A. You know, sometimes you have to pick and choose what you're going to learn because you just can't do everything, right? I know in my personal life right now, the house is a pigsty because it'll wait. The dust, the dog hair. Home is where the dog hair sticks to everything but the dog. The dog hair will wait. You know, trying to get your lectures ready and answer your emails and stuff, that's more important. So you just set that stuff aside, maybe later, right? Sometimes in class, you're like, well, I have all these other classes, I've got work, I've got family, I can't learn everything. What's the most important to learn? The most important to learn is the rules for multiplying and dividing. That's a big one. Adding and subtracting, that's a smaller one. The mix together, that's a very small thing. So if you're struggling with the concept at all, focus on getting the multiplying, dividing part first. Any other questions?